Okay, so this is another way to prove that triangles are congruent. So this is called SSS, or side, side, side. And when we have, for example, two different triangles, when we're trying to find that they're congruent, we can look at three sides that are congruent to each other. So we have side AB is congruent to EC, so here and here. Side EA is congruent to side BC. And then we have side AC is congruent to side AC by the reflexive property. So that's how we can tell that these two triangles are congruent to each other by side, side, side.
SAS, or side angle side, is another way to prove that triangles are congruent. An example are these two triangles, and this side is congruent to this side, and this side is congruent to this side, and these two angles are congruent to one another because the angles are vertical. And if we were to use this angle, this angle, this angle, or this angle, it wouldn't work because you need to use side angle side.
Okay, so here's a problem where we're going to be practicing SSS, or side, side, side. So here we're given a diagram of two triangles, and we're trying to prove that triangle LMN is congruent to triangle NPL. So the first statement that we're given is that side LM is congruent to side NP. The second statement we're given is that side LP is congruent to side NM, here and here. So keep in mind that so far we have that two sets of sides are congruent to each other. In order for triangles to be congruent to each other, we need three sides in SSS. So let's write a proof for it. So our first statement is side LM is congruent to side NP because it's given. Our second statement is that side LN is congruent to side LN because of the reflexive property of congruence. So this is LN, and as you can see, it's congruent to each other. So it's going to be the reflexive property. Then our third statement is side LP is congruent to side NM because it's given. And then lastly, now that we have three congruent sides, we can state that triangle LMN is congruent to triangle NPL, because of the side, side, side. Okay, so this is a problem that's going to be practicing side angle side, or SAS. So here we're given that triangle DEF is congruent to triangle FGD. And we're also given that side EF is congruent to side GD, which is already marked on the diagram. Next, we have that side DF is congruent to side DF. Once again, this is because of the reflexive property of congruence. So that's going to be this line across that both triangles are sharing. So what information do we need to make sure that these two triangles are congruent to each other by side angle side? And that information that we need is that triangle EFD is congruent to triangle GDF. So that's going to be these two angles. So once again, it's going to be side, angle, side, and side, angle, side.
Okay, so let's do some practice on side, 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 or side angle side. Our first pair of congruent triangles is side, angle, side. Our second pair is side, angle, side. Our third pair is side, side, side. And lastly, this pair of triangles is side, side, side.
Okay, and the reason that Kaylin said that this is side, angle, side is because there are two pairs of congruent sides and one pair of congruent angles. And the reason that this is side, 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 along with this one, is because there are three pairs of congruent sides. Okay, so here we have two different pairs of triangles. And we're going to decide what postulate they should belong under. So first we have these two triangles, and we notice that they already have two common congruent sides. And we also notice that there's a pair of vertical angles in the middle. And what do vertical angles mean? It means that the angles are congruent to each other. So right now, I'll just go ahead and draw this in. And that lets you know that now these triangles are congruent by side, angle, side. Next, we have another drawing over here. And this drawing already has two pairs of congruent sides. So same as we started before, but this time, instead of sharing an angle, they're going to be sharing a line segment, which is right across here. And as we know, this is going to be congruent to itself because of the reflexive property of congruence. So let's just go ahead and tick mark this. And now, this is going to be congruent. These two triangles are going to be congruent by the side, side, side theorem. I need to do it one more time.